to our succeeding topic, or to the continuation. So actually we have now the moment of a force. So here it the moment of a force is a tendency its tendency is to produce a rotation of the body upon which it is acting about the same axis. So the moment of a force is magnitude and direction, and it is a vector quantity. So how would we be able to understand or know that a force can cause moment, or shall I say the force can cause rotation? So actually, for a force, it needs to for a force to be a moment to a particular point, it has to be a point of rotation, which is in that example or in that illustration, our point of rotation is point A, and our force is measured from a distance d, and that d would always be perpendicular from the force towards the point of rotation. So as you can see, it should always be perpendicular. So the F is located perpendicular distance d towards the projection of point A. And the moment is the product of the force times distance. So here we have moment is, or MA, or yeah, it's MA because it's rotating about point A. So it's a moment of, or magnitude of the moment, that's MA. And then D is the moment arm, or we call it the distance, perpendicular distance between the line of action of the force towards the point of rotation, or to the axis of rotation. So also that portion of A, which is I have highlighted, it's the center of moments, or the point of rotation, and is the intersection of the axis of rotation with the plane of the force and its moment arm. So diha ang atong pivot of the rotation for a particular force. And so whenever we have a moment, then we have to consider the sign convention. So for clockwise rotation, it will be taken as positive, and then for the counterclockwise rotation, then it's going to be the negative, as you can see in the illustration. So in this instance, if we try to rotate force F with D together with point A, then the rotation is clockwise. So what I want you to proceed is, we're gonna have an example after this one. So here. So example for moment of a force. Determine the magnitude of the moment about point A. To check whether these forces will cause rotation about these point A. So this is our point A, and we're going to check if what would be the magnitude of the moment there. So what we're going to do is, I'm gonna copy the figure, and I will have equation that moment is equal to the summation of moments with clockwise positive, counterclockwise negative. If we're gonna let 8 kilonewtons rotate about point A somehow, so it's going to be the product of the force, and the distance is 6, because again from the previous discussion that it's going to be a perpendicular distance referred from the point of rotation here towards this alignment of the 8 kilonewtons. So 8 kilonewtons times 0.6 meter. How about this 10? Is 10 rotate about point A, or is it going to be a moment about point A? No, because 10 will only pass through point A. Any point that will pass through, any force that will pass through a point of rotation will not cause any rotation. So therefore, that is 0. So if you'd like to write that in the equation, it's 10 times 0 because there is no moment arm. So M is equal to 8 times 0.6, and the answer is 4 kilonewtons meter. And the rotation, by the way, this is negative because the rotation is counterclockwise. So ang iyong point A is in clockwise direction. As you observe, this 8 will rotate about point A. So there, we have a counterclockwise. And that's our final answer. Okay, how about this second figure? For this second figure, we're tasked to solve for the moment at point B. So this is our point B, and we're gonna rotate all the forces about point B. So we're going to investigate. Okay, so let's investigate first the forces. This force will not cause any rotation about point B as it's going to pass through point B. Also, this force 20, because it will also pass through point B. So again, any force will pass through a point of rotation, then it's not going to be included in the analysis. So starting with moment equal to the summation of moments, clockwise positive, counterclockwise negative. So let's start with this 5. 5 will cause rotation with a counterclockwise. That's negative times, this is the moment arm because the perpendicular distance towards point B is this one, 1.2. So that's 1.2 of a meter. And then let's proceed with this one, the 22.5. So 22.5 will rotate about point B, since moment and directions of force, that is the rotation, clockwise. So it will rotate about point B with a clockwise direction. So it's plus times the moment arm is the distance from this force towards the projection line of point B. This is the projection line of point B, and the distance is just equal to 1.2. So that's 1.2 of a meter. This one, the 20 will rotate at point B, about point B, with what direction? So the direction is clockwise. So that's plus 20. And the moment arm is the distance from this force perpendicular. So that distance is 0.8. So that's it. So now we have the moment, and it's going to be negative 5 times 1.2 plus 22.5 times 1.2, then plus 20 times 0, and that is 37. That's newtons, sorry. So 37, so that's newtons. 37 newtons meter. Okay, and we have a rotation clockwise because the answer is positive. So again here, this is negative because, this is counterclockwise because the answer here is negative. So that's it.